data scientist from Amoy AI Labs. I'm joining you from Enugu, Nigeria, and I'll be your host for today's session. A heartfelt welcome to everyone, including the outstanding interns of this Amoy cohort. Congratulations on a remarkable journey thus far. A special acknowledgement goes to the Amoy Fellows and our dedicated team for making this session a reality. Right. Today we are honored to have an industry expert with us, Dr. Wale Akinfadeni. Dr. Adewale Akinfadeni is a lead data scientist at Amazon and adjunct professor at George Washington University. He has expertise in machine learning, deep learning, statistical experimentation, and general information theory. He has broad experience in implementing and extending ML techniques to solve practical and business problems. In the past, he has built data veracity models using machine learning and natural language processing techniques for international development and developed ML algorithms to solve problems in the renewable space. He also advises startups in the data science and artificial intelligence space. We feel honored that he has prepared this topic, getting started with generative AI on AWS for us all. Before I hand over to Wale, please carefully take note of the following. Feel free to post your questions and comments on slido.com using the event code 3412356. Come again, hashtag 3412356, and they will be promptly attended to. A Google form has just been opened.
Hi everyone. Picking up from where my colleague stopped, the Google form has been opened to collect the attendance for the interns, and in due time, the Google form link and the password to use will be communicated. The form will be open for only 10 minutes. We have pinned the first attendance form, which will be shared soon, and you guys should be on the lookout for this. And when the form has been posted, you guys will be notified of that. So without further ado, Dr. Wale, you can start now.
Yeah, thanks for the introduction, and congrats to the entire Amoy cohort for this sort of Q4. And yeah, I think you guys are investing in your future. You're sort of investing in this learning process, learning by understanding the concept, and also by doing some sort of projects driven work. So I think that's awesome. So today I'm going to be talking about getting started with generative AI on AWS. It's actually going to be a pretty high level talk. I mean, we'll get into some of the weeds of a few things, but this is not a sort of deep dive into generative AI. And I think at the end, one of the things I want everyone to go on with is, what is generative AI? Why is it important right now? What are some of the techniques that you can use in generative AI? And then I have a use case that I recently worked on at the end, which is using sort of generative AI for an healthcare application. So I think that's what I hope to achieve and cover at the end of this talk. Okay. So generative AI is top of mind for not even most business, for all businesses. A lot of sort of medium to large scale businesses, every day they wake up, they see the hype around generative AI, and they actually want to understand what is generative AI? And generally, the key drivers in generative AI is the fact that the model size is so getting really, really large. We have from a few billion parameters to hundreds of billions of parameters to probably, I think we've been hearing about sort of a trillion parameter model. So it's getting large. The generative AI technology is actually based on Transformer, and there was a paper from 2017, which is attention is all you need. And so it's based on that. And then also the key drivers are the ease of access, right? And so in some cases, you can just go and type maybe chat.openai.com and you have ChatGPT. And you can actually use that to ask questions, to interact, to do Q&A. And all. So ease of access is also something that it's a key driver. And for a lot of companies, for a lot of businesses, expectations are that they definitely want massive productivity gains, and then they want to be able to innovate at scale every time. And so that's the sort of expectation. To be honest, even though there's a lot of hype, generative AI is actually the fastest growing trend on in AI. If you look at this plot on the left, that shows sort of Bitcoin, ETH, Kafka, and days since they created the repo compared to the number of stars that it has on GitHub, you could see stable diffusion, right? Within the first 90 days, 40,000 stars on GitHub. People are using it, people are contributing to it, people are trying to get access to the repo. Same thing with ChatGPT. It actually reached the 1 million user mark in just 5 days. Compared to a lot of other companies. It took Netflix almost 40 months to get 1 million user. Twitter almost close to 25 months actually to get 1 million user. Facebook about 10 months to get 1 million user. And Instagram probably about 2 to 3 months for them to get 1 million user. So, and ChatGPT was able to get 57 million users in the first month after launch. And so it is a growing, really, really growing fast. And there are a lot of things, a lot of applications, a lot of tools, a lot of algorithms that you can use to build Gen AI model that they've just been released in the last few months. And so, yeah, it is moving extremely fast. As I mentioned today, sort of the idea is go through what generative AI is, talk about generative AI applications and foundational models, and talk about how you can get started with generative AI on AWS. And I think I'm going to end the talk with a use case, hopefully, that sort of covers the use of generative AI in healthcare. And so, what is generative AI? Generative AI has taken the world by storm because we've been able to, through consumer-facing applications like ChatGPT, we've been able to experience how powerful the latest machine learning models have become. So generative AI is a type of AI that can create new content and ideas, including sort of conversations, stories, images, videos, and music. And like all of AI, right? Generative AI is powered by machine learning models, but generative AI is powered by very large models that are pre-trained on vast amounts of data and commonly referred to as foundation models. So you would see me use sort of generative AI and foundation models interchangeably, but just know that I'm talking about the same thing. So most times, a lot of the models that powers generative AI are actually called foundation models. And so now the next question do you think is, yes, generative AI uses large language models, very large language models actually. How is generative AI different than any type of AI, like machine learning or deep learning? And so the traditional forms of machine learning actually allows us to take simple inputs. This simple inputs could be numeric values, for example. It could be categorical values, it could actually even be sort of unstructured inputs, right? So you have text, you have images, and of course you have to create a vector representation of this input, right? And then you map them to simple outputs, like predicted values, right? You know, classic computer vision sort of application. Is this a cat or a dog, right? You can build a convolutional neural network end to end, and you can do that, have a binary outcome, right? Now, we sort of deep learning, like I said, instead of the input to be numeric or categorical, you can then take these complicated inputs. So videos, images, text, and you can map them. You know, you want to identify an object in an image, you can do that. But now, with generative AI, you can leverage massive amounts of complex data. So complexity of the data, yes, and also the mode of the data. So you can have this multimodality where you can have text, you can have everything together. And you can use this to capture and present knowledge in a more advanced way, right? So you can map these complicated inputs to complicated outputs. Like you want to extract a summary and key insights from a large document. So you can actually use generative AI to do that. Okay. Next, let us talk about some of the common use cases that you'd see that people are using generative AI for. One of it is so you can use it for text generation, right? So you can extract, you can generate text. You can use it for question and answers. You can take a huge amount of text and sort of summarize it. You can extract text from document. You can sort of paraphrase and rephrase text. You can use it also for search, which is really good. We've been sort of seeing the use of generative AI for code generation, right? So things like at AWS, you have something called Code Whisperer. We have GitHub Copilot that you can actually use as a companion. You can use it for generating images, for classifying images, for generating audios from text, and also for generating videos, right? So there are a lot of use cases. I mean, there's probably more than this, but these are some of the general ones that covers some of these three modalities, sort of input data modalities. So text, images, and videos, and then audio. In terms of the application, they're just too much. And they're just too much because I pretty much see the applications every day, and I work with people that are actually using generative AI in their application. So we're seeing a lot of in travel and hospitality, question answering, search, conversational AI is very common. In healthcare, people are beginning to use generative AI for protein folding, for drug development, personalized medicine, medical imaging, for example, and also medical summarization that we'll go through. In media and entertainment, they begin to use it for synthesizing phase, for preserving film, for generating games, and even for trying to upscale content. Used in autonomous vehicle to design parts for fuel efficiency also. In financial services for fraud detection, where you have highly imbalanced data set and sort of sometimes the signal to noise ratio is not good. You can use this to summarize annual reports, you can use it to review portfolios. In consumer goods, you can use it to optimize pricing. You can flag product brand. It's using energy, it's using technology and hardware, just everything. People are beginning to develop generative AI applications for different business use cases. Okay, next, let's talk about some applications and also talk about foundation models. And in terms of the applications, I will just quickly go through Gen AI application example, when you have text, image, and video generation, and then also another use case is actually in personalization of or recommender system. And so in terms of text generation, you can do summarization. And so you can take an input And then you can have like summaries of scripts. You can also have like in call centers, for example, where people receive calls and the transcript is very long. You can actually identify which is the customer, which person is the call center agent, and then you can actually create a sort of summarized transcript from that. Can also use it as a reading assistant, for example. You can use it to detect toxicity, use it for comprehension, for point-by-point summaries, and also you can use it as a writing assistant. You want to rephrase lines, you want to write news items, emails, sometimes you can use it. And in terms of sort of this text use case, these are sort of general stuff that you can use it for. So marketing, legal, HR, in finance, in pharma, in education, and also you can use it to improve productivity. And so these are text generation examples per industry. Now, let us look at this image sort of generation and transformation, right? On this slide, you can see some example images that are generated using stable diffusion, right? This interior that you see on the left does not exist, the living room. And so this 3D depth to image allows you to have sort of seamless image transitions. And you can see that. So you can see you can have image transformation based on that. And then if you look at the sort of the face of the tiger, Stability AI actually introduced a diffusion model that can help you upscale images. And so what you can do is that you can use it to enhance the resolution of an image by a factor of 4. And so here, what we've done is take a 128 by 128 image and then upscale it to 5512 by 512. And I think even now with the V2 of stable diffusion, you can actually generate 2048 by 2048 or higher. So you can sort of do 8 times, 16 times upscaling of images with generative AI. And so with generative AI, customers can add machine learning based recommendations to chatbots. And so you can create sort of AI generated marketing content to that specific segment. So you can automatically generate engaging descriptions of products that are human readable. And also you can sort of summarize recommended content. So you can take a news and you can do that. And so you can have like you can use generative AI to do a use case personalization. You can also use Gen AI to extract more impactful information from descriptions and reviews. You can sort of generate embeddings. So these embeddings are sort of numerical representation of a text or image called a vector. And then you can use that to drive better semantic understanding of the relationship between different items. And so you can extract information, you can generate embeddings, you can basically improve the quality of the recommendation that you give to people with generative AI. Okay. So let's talk about a little bit about foundation models. And I said, the models that drive generative AI are sometimes called foundation models. And so you see me use foundation models in this part a lot. Okay. So why foundation? Any questions or am I good? Okay. In traditional machine learning models, you have labeled data. In traditional supervised machine learning models, you have labeled data, and then you have your ML models, and you want to use your ML models for different tasks. So you're doing text generation or summarization or information extraction, Q&A chatbot. You take different ML models, you train with your labeled data, and then you deploy the model. And so what you have is that you have this task, this sort of domain task that you want to do. And so that is the traditional ML models. In terms of foundation models, it's different. You have really, really large data set, extremely large, that is unlabeled. You first do a pre-training task with your foundation models, and then you adapt that to your task. And so this is sort of called domain adaptation, where you take the foundation models and you adapt to the different tasks that you're trying to do, whether it's information extraction or summarization or text generation. And so that is sort of the difference, and why we're using foundation models. So which is you don't have like sort of multiple models for the different tasks, but you can actually have like a pre-trained model, one large model, and then you adapt it to the task that you're doing. But again, there's this sort of fruitful diversity of foundation models. And the fruitful diversity actually comes from the modality of the data, right? So an input, summarize the articles on the impact of working on heart health, right? And so the foundation model is sort of a text to text. And so the modality on both sides is actually text to text, right? Same, and you generate text from simple NLP, and then it gives you an output. You can ask a question, for example, and then you have a text to embedding. And so what that does is it generates numerical representation of the text for search and finds similarities. And with that, you sort of have like a numerical representation, which is actually these embeddings that are given to you. You can also sort of ask, can I get a photo of an astronaut riding a horse on Mars? And with that, the sort of modality is different, because now you have sort of multimodal foundation models, right? You're going from text to images, and it actually generates and edits the images from your natural language prompt. And so, yeah, it has sort of a fruitful diversity. So we've talked about generative AI, how incredible it is, how awesome it is for your business. You can use it, it's diverse, it's large, it works well a lot. But also there are some limitations to keep in mind. And I think it's extremely important right now that we're sort of in this time where there's a lot of hype. There's a lot of people, of course, that call themselves enthusiasts. There's a lot of promises that generative AI can do everything. But also there are some limitations of generative AI models. And this is asking what are the limitations of LLMs, right? And it came up with some pretty good responses. So there's a risk of bias, because some of these data set that the foundation models were pre-trained on, they have sort of inherent and intrinsic bias in them. And what happens is that this model just explodes the bias, right? And so there's a risk that you see. Sometimes the context can actually be misinterpreted. You see that a lot. I've also seen people say, some they lack common sense, because sometimes, very sort of simple mathematical formulation is probably not going to tell you what the answer is. And then the inability to reason logically, I think that's also something that is important. And sometimes the sort of domain-specific knowledge is limited. So if there's a new thing that just came out, maybe it's going to be difficult to see. So these are the response that it came up with. But there are a lot of response that was missed. Very crucial aspect is that, yes, the limitation is that it hallucinates. I mean, there are a lot of ways that scientists that we've been trying to solve this hallucination problem, and I'll talk about it soon. Sometimes you have the knowledge cut off. Sometimes also it's good because there's a potential that you should have some sort of content moderation, so a human in the loop. And then, yeah, in terms of references, it is pretty poor because it gives you something and then gives you different references entirely. And then there's no explainability, at least as a Spring, which sometimes there's some continents where, for example, the European Union GDPR, there's some, they have their compliance framework such that there's some things that you want to do that if you have to use generative AI, it's probably impossible, right? And so, for example, you're trying to use it to make decisions for humans, you have to be able to explain that. And if you can't, then that's a problem. Okay, there are a lot of things you can do, but these are just 5 examples that you can use to sort of make foundation models, generative AI work for you. One of the coolest one is prompt engineering. Prompt engineering means that you're taking this pre-trained model, and you're not fine-tuning or training from scratch, but you're trying to make sure that the prompts that you're giving it is working perfectly and you're getting what you want. So the different type of prompt engineering, there's sort of a single shot prompt that you probably do every day with your ChatGPT. There's also few shots prompting, and then there are a lot of different techniques that are actually using classical computer science technique to do prompt engineering. So there's a chain of thoughts, there's a tree of thoughts, really, really awesome things that you can do to actually make the results better. Fine-tuning, I'm actually always an advocate of fine-tuning, is that if you can take a model, it doesn't necessarily need to be the very large foundation models. It can be pretty small. And if you can fine-tune, which is a form of transfer learning, to your data set, the results are spectacular. And so fine-tuning also, and of course, there are a lot of caveats, when you want to fine-tune, such as, compute, but also there are a lot of other methods that you can use to fine-tune. There's something called parameter efficient fine-tuning, that actually uses some sort of matrix, classic matrix decomposition, classic methods to make sure that you're not fine-tuning all the parameters, and it makes it faster. You can fine-tune your model on your data set probably half of the time using this parameter efficient fine-tuning known as PEFT. Another one that has sort of been blowing up recently is RAG, which is this retrieval augmented generation. So RAG is an AI framework for you to improve the quality of LLM generated responses. And what you do is that you ground the model on external sources of knowledge to actually supplement the internal representation of information in your current LLM. And so implementing RAG in sort of a foundational model-based system has like a lot of benefits. You make sure that the model has access to the most current and reliable facts, and also make sure that the users that are using it have access to the model sources, and it ensures that the claims can be checked for accuracy and also be trusted. I've also seen sort of modular reasoning where you sort of put some apply logic to make your foundational model work for you. And then also there's a content moderation that I've mentioned that sometimes you need a human in the loop to be able to moderate this content. Okay. There are many roads to foundational models, but sometimes choice is key. There are the proprietary models, there are the publicly available models, and also you can build your own model from scratch if you have tens of millions of dollars for compute, for example. I mean, it depends on the size of the model, but there are different use cases and applications that will require different families of foundation models. But one thing I really, really like, and I think I mentioned it, is sort of this rise of open source, where every single day there's an open source model. There's Stability AI actually launched language models called Stable LM. Before you know, there's the Llama, for example, there's a family of the Llama from Facebook AI. There's the sort of Llama 1, Llama 2, the 13 billion model, there's a 70 billion model. And for a lot of them, you can actually use them as pre-trained, you can fine-tune them. And so major companies and sort of startups, so startups from Anthropic to Cohere to Hugging Face, they are beginning to sort of open source these foundation models. And it is getting really, really exciting. And so, and then there are the sort of open instruction tuned LLM. There's also some of the Flan C5 that I'm going to talk about a little bit. And so there's a rise of open source foundation models that people can use. So let's bring it all together. And for you to be able to sort of successfully build a generative AI application, there's a lot of things you need to think about. The application layer. So if you have like an application development stack, you want to make sure that you're building it. You want to make sure that your ML ops, operationalization of your ML is ready for foundation models. You also want to think about the ecosystem of your model. So, you want your fine tuning to be easy. You want better hosting options. There's a broadness of choice. You're thinking about the security and governance of the data that you're using, and also, of course, ML ops. Ease of integration is also important when you're trying to embed foundational models to existing tools. And then there's the hyperscale compute. You want to make sure what kind of compute you want your compute to be scalable, of course. Are you using sort of a managed instance, integrated elastic, or do you want it to be some sort of pay as you go? And also there've been a lot of advancements into silicon based that are cost effective with low latency. And so putting all this into consideration is actually one of the best ways to build Gen AI applications. Okay. How can you get started with generative AI on AWS? We have something called SageMaker that you can actually use to build machine learning models. It's sort of a machine learning ecosystem that you can take and build end to end. And SageMaker Jumpstart has a lot of the public and also some proprietary FIMs, a lot of models that you see in Hugging Face. You can actually customize and integrate them into your generative AI applications with Jumpstart. So, it has an interface that you can browse public foundation models. You can experiment with them. You can take them and customize, and you can to your own data without training from scratch, which means you can fine tune. And then you can actually deploy the model and run inference. So there's readily available compute for you to do that. And so that's one. This is Jumpstart. The second one is Bedrock, which actually went generally available recently, a few weeks ago. And you can sort of use that. This is more of using an API. And so which means you don't need to manage infrastructure yourself. And so there are a lot of, so you can choose different foundational models. AI 2.1 Labs models are there. Anthropic is one of the leaders in sort of generative AI. They have, the Claude sort of Gen AI models that I've actually used, and they're incredible. Stability AI also. And so all sort of the big players, they have all their models that you can use as API on Bedrock. And you can also privately customize foundational models with any sort of your data, and you can enhance data protection because you're trying to make sure where your data, where you have your data, that you're using some of the security capabilities. And you can use the different tools on like the AWS ecosystem to build end-to-end, which means that you can use it to deploy you can your generative AI applications such that they're scalable, they're reliable, and they're secure. So that's really good. And so this last set of slides, it's just going to be me walking through sort of a Gen AI use case with an LLM, but not an extremely large model, but a model that actually works very well. And I'll go through that. So in a typical workflow, a radiologist actually supervises, reads, and interprets images, right? So I don't know if anyone has gone to the radiologist before. And so when they do that, they have something called radiology reports, and they have findings in them. And so then they concisely summarizes these key findings. And these key findings, this summary is actually called impression. And so this impression, they help clinicians and patients to focus on some of the critical contents of the reports that actually contains information for clinical decision making. And so in the key sections that you see is actually such that you have like the background, and you also have the findings in radiology reports. And so this is actually a blog that you can check that I recently wrote on using Gen AI for radiology report. And so what we did here is, on the left and the right is SageMaker Jumpstart. take a large language model from SageMaker Jumpstart known as the FLAN T5XL, and fine-tune that for a clinical radiology report summarization task. And then we compare the predictions with some ground truths and evaluate the results using something called the Rouge metrics. And what we try to do is actually to demonstrate that a model that you sort of fine-tune for this specific task actually returns better results than you just using a pre-trained model on a generic NLP task. And so, it was a clinical data set. The training data set is publicly available from Mimic CXR, which is chest X-ray data set from sort of Beth Israel Hospital in Boston, in Massachusetts. And we sort of validated with 5% of the data set. And we had 2 evaluation data sets. The first one is coming from the same Mimic CXR data set, and it's called Dev1. And then the second one is Dev2 from another hospital system called Indiana University. And the reason why we did that is that we want to try to see if our model actually generalizes to like a different set of data set, that has like a different distribution. And so the fine-tuning is that you have your general data, you have your pre-trained model, you fine-tune with clinical data, and after fine-tuning with clinical data, what you are actually then trying to do is that you fine-tune and you create a summarization task. And so this is sort of how the solution architecture looks like. And you have your training data set, you're sort of processing, you're using SageMaker to do your model development, and you have an inference. And there are 2 things we also did. We developed a web app with Gradio, and it was hosted on EC2 on AWS. And also there's a dashboard that you can use to sort of compare results from the bucket. And this is to make it easier for the users, which are the clinicians, to actually interact directly with this. The evaluation metrics that we use is something called the Rouge score. And so what it uses, it compares something that is automatically produced against like a reference. And so you have like the Rouge one that looks at the overlap of the unigrams, Rouge 2 overlap of bigrams, and then there's the sentence level metric, and then there's also the summary level metric. And so we evaluated using the Rouge score. For these are sort of what the results is. This is a pre-trained model, sort of without even using, without fine-tuning. And when we fine-tune, the Rouge 1 score, for example, we have 3 times much better results than that, right? And so we saw on Dev1, we saw a 38 percentage point improvement in sort of disaggregated Rouge score. And in Dev2, there's like a 31 percentage points and 25 percentage points improvement on that. So which is pretty good. This is a dashboard that I created sort of using QuickSight, also AWS. And the idea is that if you have some findings and you have, you can actually see the Rouge score for each one and also what the generated impression looks like. And so with that, you can have a human in the loop that comes in and sort of check and give feedback based on this dashboard that you're showing, sort of some of the reports and how the summary of the impression and also the metrics. This is sort of an example of a radiology finding, and this is sort of what the generated text would look like. So you can see the impressions on the right, and you can also see the findings on the left. And yeah, so this is there are a lot of recent sort of future work that we're going through. We're trying to expand to a bigger data set. That is actually looking at chest X-ray. So we want to look at other things like MRI and CT and sort of more information for that, and also multiple modalities. We want to find more complex reports, for example. And we also want to check criticality. So if you take a report, if you generate sort of the impressions, also, can you tell the radiologist that this is critical? This is the criticality for this impression is low, is medium, is high, depending. And then with that, there will be a follow-up recommendation. And then also a feedback sort of mechanism that you set a feedback loop to enable radiologists improve the performance of the model over time. And so there's a lot of different things that we're actually currently working on with this open source data, to also showcase some of the strengths of using Gen AI in sort of in healthcare. So I think, yeah, that's pretty much everything that I wanted to present. This sort of last part that I went through, there's a blog post for it, and also there's a code. The code is on GitHub. I published it, and everyone can actually take a look at it. I'll put the link in the chat so that everyone can see it. But so yeah, thanks everyone. Thanks again. And yeah, I'm on Twitter. I'm on LinkedIn. You can follow me. Yeah.
Thank you very much, Mr. Wiley, for this session. So we have some questions for you. So I'm just going to be reading the questions that we have. Give me a minute, let me get to them. So one of the questions we have is, how expensive is it to deploy Llama 2 with AWS? I've been trying to, but the process seems complicated. I basically need an API endpoint for text completion.
Sorry, which of the Llama 2? Is it the 70 billion parameter? Does the person know?
Okay, so I don't quite know if the person who asked the question is...
Okay. I think I saw it's a 13B.
Okay.
So how expensive it's not a question I can answer directly, because you can actually deploy easily on Jumpstart, but also it depends on the compute that you're using, right? And so the cost depends on the compute that you're using, and also depends on a lot of factors. What's the latency? What latency are you looking for example? And so yeah, but it depends on the compute. Some of them can probably, I don't know, maybe go from like a few dollars an hour to maybe cents an hour. But it mostly depends on the compute. Yeah.
Thank you very much. Another question for you, Dr. Wale, how to fine-tune the foundation modules?
Sorry,
Okay.
to button. So before we continue with the questions, we want to tell you about the second attendance form that will be dropping now. The secret code is Python, all lowercase, and the form link will be sent very soon. Check YouTube and check Zoom for the new form. And nobody should please complain that they were on the call, but they didn't know it has been announced now. Thank you very much. You can carry on, Ayene.
Okay, thank you, Mercy. So please go ahead and fill the attendance form as it's getting dropped on the respective platforms. All right, so the next question, Dr. Wale. So the question is how to fine-tune the foundation models that you mentioned to do the specific work. I think to fine-tune the foundation models. Yeah.
I mean, there are a lot of ways to fine-tune, but the sort of the radiology healthcare project that I just showed, it was fine-tuned. It was fine-tuned on SageMaker. The code actually is on GitHub. It's on AWS samples GitHub, and so it's straightforward. It's even better that you can use parameter efficient fine-tuning, and so there are a lot of different ways that you can, Hugging Face, for example. So they have code samples that can help you fine-tune. So, like I said, it also depends on the compute that you're using. It depends on the size of your data set, but yeah, it can be fine-tuned. Yeah. And then it depends on the model. So some, like the really, really large models, a lot of them are not available for fine-tuning, like GPTs and co, but there are sort of still very large models, but tens of billions of parameters that you can actually fine-tune.
All right, thank you. I hope that answers the question for whoever asked the question. And then there's a new topic on LLM ops, right? So what is it about?
It's the same thing. It's what I just went through right now, which is LLM ops is operationalizing your LLM, and so which is you using LLM in your ML product. So how do you operationalize it? Do you want to fine tune? Do you want to do prompt engineering? What are you using to deploy? What's the latency of your inference? It is the same thing as ML ops. Yeah.
All right, thank you. So the next question here, we said someone is asking, how do I start deploying my BAT model on the cloud? I've already deployed it on Hugging Face, but what are the steps for cloud deployment?
Hugging Face is a cloud deployment. So I don't if you're deploying to Hugging Face, it's already a cloud deployment. But if you're talking about maybe deploying on cloud services, like AWS, there, I mean, there, yeah, there are a lot of samples that can sort of help you. It might be a little easier if you're developing the model, with on AWS, for example. If you're using Jumpstart that I was showing you, it's very straightforward to deploy. But if you bring in your model from outside, you can actually bring your model, containerize it and bring it and adapt it to cloud. But yeah, there are a lot of sort of starter code, a lot of examples that can help you deploy your BAT model on AWS.
Okay, still on BAT. So someone here says, I've used BAT transformer, but I couldn't fine tune it. How can I work around this issue? I always get stuck on fine tuning.
If you've used BAT transformer, you haven't fine tuned it. So I don't know, is the person on, I don't know if the person is here. Because if you've used it, it means you've somehow fine tuned it for your work.
Okay, the question was posted on Slido, so I'm not sure if the person is on Zoom, but we're going to try to see if we can get the person from YouTube as well. So in the meantime, though, let me get to the next question. So we have, I also wanted to know more about generative adversarial networks and how I can work with them. I wanted to use them for data set generation.
So you said the person wants to use GANs. Yeah, so GANs are probably out of fashion now. But yeah, GANs is sort of a prominent, I think it's a framework that started as Iron Goodfellow in 2014. So that's 9 years now, the GANs. And so the idea of GANs is that you learn to generate new data with the same statistics as the training set. That's what GANs are. And it's sort of this ML framework that you can use to do that. I mean, there are a lot of code samples of using GANs online. And the idea sort of around GANs is based on a lot of the sort of mathematical properties. And so you get information on a training set and you try to use that to sort of create, additional information. And so this additional information could be additional images or some images that resemble the training set. But you can use a lot of these new generative AI models that they probably work better than GANs. So stability, for example, stability might do way better than that. There's the DALI. There's also the new sort of GPT coming out where you have a multimodal, like the GPT-4 vision, where you can actually give it an image and you can tell it to create more images like that. And so I think GANs are pretty cool. You can always set them up, but they're not state of the art. Oh, okay. Actually, I think I saw the person that asked the question. Okay, it is bats, not. I thought it was bats. Okay. I wasn't able to specify the parameters I wanted it to fine tune for. Are you using Hugging Face? You can just type yes or no, Ash. Okay. Yeah, you might be able to. It depends on what you're trying to do. It depends on the parameters that you're trying to. Yeah. I mean, for me, I use Jumpstart, and that's a little straightforward because you can set up your hyperparameter. You can say if you want to fine tune like the last layer, or if you want to fine tune everything. And it is a little straightforward on Jumpstart. I'm not sure about how Hugging Face fine tuning BAT works, but what I can tell you is that there is a very strong community on Hugging Face. Probably you should go and like ask the questions. You know, if you cannot, you should be able to specify the parameters, I think. But if you cannot, Hugging Face has a really good community that you can ask questions and they'll respond to you. Okay, awesome.
All right, thank you very much, sir. So there's one last question, which is a bit more generic. It says, is there a means to write and get AWS or Azure certifications for free?
Free. I mean, I can't speak about the other one that you mentioned. But I can speak about AWS. I don't know, to be honest. I think there might be maybe some scholarship that they release once in a while, but I don't even know if there's anyone out. So they typically release, I think they have like applications to do that, but I really don't know what the timeline looks like for some of these certifications, I would say.
Okay, so there's one last question here. How can we manage the ethical aspect of using generative AIs in an academic or professional context?
I mean, this is a 1 hour talk. 1 hour, I can give a 1 hour response to that question. It's packed. There are a lot of ways, but I think for me, acknowledging that the problem exists goes a long way, even in trying to solve the problem, right? The ethical consideration. Having sort of discussions around it, it's very, very important. Having it at top of mind is extremely important. And also just, you know, there are a lot of ethical considerations. There's a lot of things. There's things around high P, for example. If you're using a Gen AI to produce an image, right? Is it, what if it's coming from an image that someone used their sweat to create? You know, so I feel like the first thing is we need to have more discussions around it. In a lot of countries they're beginning to have. I know in the US, they had the US Congress, they had like a discussion on forum on some of the ethical considerations of generative AI. They had a lot of the people from Mark Zuckerberg to Elon Musk to even some researchers that I personally know were also in that meeting. So yeah, it is important to have the discussion, but also it is important to also set boundaries. It is important to also make sure that you know, when you're doing something that with Gen AI that you probably feel that it's not right, maybe take a step backwards and sort of see, okay, what are the best ways? What ways can I, you know, for example, can I use it to aid my understanding of something instead of just using it to create, you know, because I've also seen stories of people using, for example, Gen AI to create solutions or answers to exams or to homework, sorry, for example, which also sort of it's it's something that there are a lot of ethical considerations around that. So yeah, I think we still need to, there should be more discussions, there should be more, people should start bringing some of these ethical concerns to limelight, and I think that would lead to better recommendations and improvements, I would say.
All right, thank you very much, sir, for that. There's Mayan Kalu, so you can unmute yourself and ask your question. Mayan, or you can just type the question in the chat box. So. Okay, so I'm going through the chat box now, and I can see another question from Victoria Mbaka. She says she undergrad background that is not in computer, but she's interested in data science, and getting a job is very difficult. So what advice would you give about this? Okay, yeah. I was just going to conclude that she's attended one bootcamp already, but recruiters ask for applicants with computer science background.
Yeah. Victoria, I was probably in your shoes some years ago, because I also do not have a background in computer science. Didn't take any formal computer science course before I got my first job. But the honest truth is that first job is always very difficult to get. It's because you're competing with a lot of people, so it's always very challenging. But sometimes all you need is just that first job, and after that, everything just becomes much better. But there are a few things. Some recruiters will say they want someone with computer science background. Some they probably don't care. But I would say, don't stop. Don't take notes for an answer, even if they say they want computer science background. Just keep applying, but also get good feedback. So timely feedback. What am I doing wrong? Do I need to improve my resume? To be honest, if I am trying to evaluate people, I wouldn't care that much about the bootcamp. I would actually care about what they've learned and done in the bootcamp. And so sort of learning by doing, I think, is extremely important. If you're work on projects, highlight the projects that you've worked on in your resume, put them on GitHub, make sure that the link to that GitHub is on your resume, make sure that any code you put on GitHub is clean, is readable, is efficient, you've gone through it, you have comments, you followed all the rudiments of writing code, right? And just keep on working on it and keep on improving, but make sure that your approach is sort of more project driven than maybe educational and just go apply, go interview. If you don't get applied to, and just go through that cycle and continue to constantly improve. And at some point something will come. And I think that's the advice I give to a lot of people. And so far, I think it has worked out for a lot of them. Yeah.
Okay, thank you very much, Wale. I hope that helps. Yeah. I hope that helps her. So, Mayan, I think you still have a question, and I don't know if you can unmute yourself now. Can you unmute yourself now? Otherwise, we'll move on to the next question. Okay, so we don't have any more questions. So we just want to say thank you very much, Dr. Wale, for sharing your insights and thoughts with us today. So every second we've spent here has been quite informing, quite informative and educating. So to our awesome interns and everyone who joined, I'm sure that you've picked up some really helpful knowledge, and you have a great knowledge block from today's talk. A special thanks to the hardworking Hamoye team and everyone who pitched in to make this webinar a success. Have an awesome weekend. And until next time, I'd like to say thank you and take care.
Yeah, thanks everyone.
Thank you very much, Dr. Wale, for your time.